Welcome back, students. In the last module we learned theorems based on coplanar vectors. Still one theorem has been pending based on coplanar vector. Let us discuss that theorem in this module. The theorem states that if vector a bar, b bar, c bar are non-coplanar vectors and vector r bar in a space can be uniquely represented as linear combination of a bar, b bar, c bar. That is, yes, r bar equal to xa bar plus yb bar plus zc bar, where x, y, z should be unique scalar. Let us see the proof. Let a be any point in the space. Move the vector a bar, b bar, c bar and r bar such that this a point becomes the initial point. Let now be AP bar equal to R bar. You can see the diagram here. A bar, B bar, C bar, AP bar, it's R bar. Okay, now going ahead. Now this A bar, B bar and C bar are non-coplanar vectors. They determine three planes. One plane, two plane and third plane. Yes. Now they all intersect at a common point called A, right? Now to point P, we will make a plane parallel to B bar and C bar. B bar and C bar is this way, so we will make a plane parallel to B bar and C bar from the point P. You can see in the diagram. And then we'll complete a parallelopipe. Yes, we are completing a whole parallelopipe this way. Now coming here, if you see in the diagram again, the AB bar is parallel to A bar. So can I say AB bar is a scalar multiple of A bar? So can I say AB bar equal to T1 A bar? Yes, where T1 is a scalar. Let us give the equation to this. So let us give the numbering to this equation, that is number 1. Now you can see AQ bar. Yes, AQ bar is parallel to B bar. AQ bar parallel to B bar. So we can say AQ bar is a scalar multiple of B bar. That is AQ bar is equal to T2 B bar. Yes, T2 is a scalar. Equation number 2 to this expression. Similarly, if you concentrate on the diagram, the AS is parallel to C bar. So now AS bar is parallel to C bar. So can I say AS bar is a scalar multiple of C bar? So can I say AS bar is equal to T3 C bar with scalar T3? Yes. Give the expression to be 3. Now we will be applying a triangle law in this parallelopipe. Please concentrate on the triangle law. By the triangle law, you can see that AP bar is equal to AC bar plus CP bar. I repeat, AP bar is equal to AC bar plus CP bar. Now, therefore AP bar is equal to CP bar plus, now this AC bar, again we'll apply a triangle law. Now this AC bar is AD bar plus BC bar. It's highlighted with the blue color in the diagram. So now can I write AP bar is equal to AB bar plus AQ bar plus AS bar? Now you'll be thinking how sir got AQ bar and how sir got AS bar. Students, you can see in the diagram AQ bar and BC bar are equal, as well as AS bar and CP bar are equal. So instead of BC bar I wrote AQ bar, and instead of CP bar I wrote AS bar. Now you know AP bar is R bar, AB bar is T1 A bar and AQ bar is T2 B bar, and AS is T3 C bar from equation number 1, 2, 3. Let us substitute here. So what we get here is R bar equal to T1 A bar plus T2 B bar plus TC B bar. So we showed that R bar, any vector in a space, is a linear combination of A bar, B bar, C bar. But uniqueness is still not proved. Now for uniqueness, let's start with the proof. Let R bar be equal to T1 A bar plus T2 B bar plus T3 C bar. Equation number 1. And R bar equal to lambda 1 A bar plus lambda 2 B bar plus lambda 3 C bar. Equation number 2. Currently I have assumed that both the scalars are not unique. Now subtracting 2 minus 1 on the left hand side, we get null vector which is equal to T1 minus lambda 1 A bar plus T2 minus lambda 2 B bar plus T3 minus lambda 3 C bar. Now to make a null vector, the right hand side should be null vector. But A bar, B bar, C bar are non-coplanar vectors. And the non-coplanar vectors are always a non-collinear vectors. And the non-collinear vectors are always a non-zero vectors. So to make a null vector, this t1 minus lambda 1, t2 minus lambda 2 and t3 minus lambda t should be compulsory 0. So t1 minus lambda 1 equal to 0, t minus, yes, it gives t1 equal to lambda 1. t2 minus lambda 2 equal to 0, it gives t2 equal to lambda 2. And t3 minus lambda 3 equal to 0, it gives t3 equal to lambda 3. So my assumption is wrong. These two scalars are not different, they are equal. So we got here unique linear combination of a bar, b bar and c bar. Now students, for coplanar vectors, we have to prove it. What all things? Number one, if three vectors are coplanar, you can prove any one vector is a unique linear combination of other two vectors. For example, c bar is equal to t1 a bar plus t2 b bar. So I can say that c bar, a bar and b bar are coplanar vectors. Another way to prove the coplanar vectors is the three vectors a bar, b bar, c bar are coplanar if the linear combination, that is xa bar plus yb bar plus zc bar is equal to null vector. And another way to prove that a bar, b bar, c bar are coplanar, we have to prove that box product a bar, b bar, c bar equal to 0. Students, box product, and this we will study in the further modules, and we will be using more for the coplanar vector. That's a box product. We will see in detail in the next module. So please remember all these coplanar vectors, theorems and the statements. Thank you.
10 15 20 22 60 आएगा 15 चौका 60 और 20 के 60 13 ही रहेगा।